This video goes along with modules 34 through 36, in which we will discuss the advantages and disadvantages of many non-renewable energy resources. Well, you can look through your essential knowledge statements here if you want. If you don't, that's okay too. So, non-renewable energy is used everywhere on our Earth. Fossil fuels are any fuel from biological material that become fossilized millions of years ago. They provide most of the energy used in both developed and developing countries, and the majority of fossil fuels we use, like coal, oil, and natural gas, are from deposits of organic matter that were formed between 50 and 350 million years ago. These are all examples of non-renewable energy sources because we have a finite supply. As they say in my favorite car commercial from back home, when they're gone, they're gone. And we are not going to get any more of these. Nuclear fuel is also considered to be a non-renewable, even though, as we will see, it tends to be better than the rest. The types of energy a country uses depends on what is available and what is affordable. So in places that are abundant in coal, they're going to have generally a larger percent of their energy coming from coal over maybe natural gas if they don't have access to a lot of that, or if it's too expensive to get natural gas to them. However, we are seeing an increase in renewable energy worldwide, which is encouraging, but we'll look at more on that next time. These graphs show worldwide patterns of energy. So worldwide, you can see that most of our energy is coming from oil, followed by coal, natural gas, renewable energy, and nuclear. You can also see the comparison of a country's total annual energy consumption and their per capita energy consumption. So I think it's interesting to look at a place like China where their total annual energy consumption is the highest, but their per capita is one of the lower ones as well. And I know these graphs may be a little outdated, but I still think it's worthwhile to look at those trends because they haven't changed a whole lot. I also think it's interesting that Canada has one of the highest, actually the highest per capita annual energy consumption, but does have one of the lower total energy consumption values. This looks at patterns of energy use in the United States. So on the left, you can see the popularity of a variety of both non-renewable and renewable energy resources. Oil has been number one for quite a while, and I don't necessarily see that changing anytime soon. Down at the bottom, we can see that renewables has taken off. Okay, we're seeing a little bit of an increase there, but I think it's going to be a while before it is up as high as some of the things like natural gas and coal. We have also seen a pretty big increase in nuclear uses over the past several years. And then we can see the United States breakdown pie chart. We are mostly using oil and natural gas for our energy supply needs. I think what's a little bit alarming is that 82% of that is coming from fossil fuels, with only about 18% coming from renewable energy and nuclear fuel. That's a problem. And then below that, you can see, like, where is that energy going to? Is it going for transportation? Is it going towards residential? So like you and your house and things like that. How do we know what type of energy to use? Well, it depends on what your purpose is. We are able to quantify energy efficiency by looking at the EROEI, which is the energy return on energy investment, and that's calculated by dividing the energy obtained from fuel by the energy invested to obtain fuel. So the larger that value is, the more efficient that energy type is. And so let's look at an example here of how efficient coal is. So there's our energy resource, and those little red arrows show losses. So there is energy loss during extraction, transportation, processing, combustion/conversion, electricity generation, and disposal, the electricity transmission until all the way it gets to you, the end user. And so all of these losses make coal only about 35% efficient. And we use it all the time. You might even be using some coal somehow in some way to be watching this video and listening to me talk about who even knows what. So let's look at electricity for a second here, because that's going to come up. And that's going to account for 40% of our energy use. But keep in mind, it is a secondary source of energy because we obtain it from converting a primary source like coal or natural gas. An energy carrier is something that can move and deliver energy in a convenient, usable form to end users. About 40% of energy consumed in the US is used to generate electricity, but all those conversion losses during the process used to generate electricity, only 13% is available for end users. And that's low. That's a problem. We do need to be working towards making things more efficient, even if we are using non-renewable resources. Let's look at the process of electricity generation. It is produced by a conversion of primary sources of energy like coal, wind, or natural gas. And the transfer of energy from fuel to electricity is, like I said, only about 35%. All thermal power plants work in basically the same way, regardless of the fuel type, and we'll look at that in a second. So essentially what these power plants are doing is they're converting potential energy of a fuel into electricity that we can use. Because like you holding a piece of coal over your phone is not going to charge. It needs to be converted into electricity first. So here's what's going to happen. Whatever the fuel is going to be delivered to a boiler where it is burned. And burning that fuel transfers the energy to water. And so that water is going to become steam. The kinetic energy contained within the steam is transferred to the blades of a turbine. So that steam, as it steams, is going to turn the blades of a turbine. And as that happens, the shaft in the center of the turbine turns a generator, which is what is going to generate the electricity. That generated electricity is transported along an electrical grid, which is going to connect power plants to each other and link them to the end user. And then after the steam passes through the turbine, it's going to be condensed back into water. Almost always, that water is going to be cooled back down before it goes back into whatever body of water that power plant is dumping in. If it doesn't, we have some serious issues with thermal pollution, in which the water around the plant is going to become too hot for the things that live there. And as we know, lots of organisms have a very narrow range of tolerance. So even a 1 to 2 degree difference can be huge for some of those aquatic organisms. But I think most places are going to cool that down before they release it back until it's at least close to whatever that body of water's temperature is. And so here is a picture of what I have described. So again, we have the boiler. That thing, in this case, coal, is going to be burned to produce steam to turn a turbine. The turbine turns the generator. When then that transmission line is going to go, I don't know, to your house, to our school, anywhere. There are different ways to increase the efficiency of electricity generation. In some places, they used a combined cycle where the power plant uses both exhausted gases and steam turbines to generate electricity. When we talk about the capacity, that is the maximum electrical output of a plant. In the US, that capacity is about 500 megawatts, but we generally measure home electricity in kilowatt hours. However, we know that these plants are not running 24 hours a day, 365 days a year. So we also have to consider the capacity factor, which is like how much time the power plant is operating within a given year. It will not be 24 hours a day, 365 days a year. Maybe it's down for maintenance for a while. Maybe something else happens, but we're not that good. Some other places will also use cogeneration, where they're using a fuel to generate electricity, but also produce heat. And then that heat could be used to like heat the building. So you're not having to use that electricity as well. You're repurposing. So that would also increase the efficiency a little bit. Next, we'll get into the details of each of the non-renewables. Coal is the most abundant on our Earth. and it is the dirtiest fossil fuel. Coal is a solid fuel formed primarily from the remains of trees, ferns, and other plant materials that have been preserved from 280 to 360 million years. There are three types of coal: lignite, bituminous, and anthracite. We also will sometimes talk about peat, which is the precursor to coal, and it's made up of partly decomposed organic matter, but it's not there yet. The largest coal reserves are in the United States, Russia, China, and India. This diagram shows the progression of coal from peat all the way through. And as you can see, it takes literally hundreds of millions of years for that to happen. There are some advantages to coal. One, it's energy dense. It is plentiful. It's easy to get by surface mining, so we're not having to dig like super far down into the earth. It needs little refining before we can use it. It's inexpensive, and it is also easy to handle and transport. That is not an advantage for any of the other ones. However, there are lots of disadvantages of coal. Coal does contain some impurities like sulfur. So when it's burned, that sulfur is going to be released into the atmosphere. And as we'll see later, sulfur can lead to some not so great things for our Earth. It also contains trace metals like mercury, lead, and arsenic. The combustion of coal does lead to increased level of air pollutants, and that ash that's left behind can lead to runoff and pollute waterways. And, more carbon is going to be released into the atmosphere when we are using coal, and that is a problem. Moving on to petroleum, which is cleaner than coal. Petroleum is a fossil fuel that occurs in underground deposits composed of a liquid mixture of hydrocarbons, water, and sulfur. The fluid nature of petroleum products like oil and gasoline make them more suitable for mobile combustion. Like that's why we use them for our cars. They're formed from the remains of ocean-dwelling phytoplankton that died 50 to 150 million years ago. And they're going to be found in areas where porous sedimentary rocks are capped by non-porous rocks. And that's going to form a dome. And we're going to have to drill wells into a deposit to extract that petroleum with pumps. After it has been extracted, it is transported to a refinery. Maybe it's through a pipeline, maybe it's not. And then crude oil is the liquid petroleum that's removed from the ground. And that's going to include tar, asphalt, gasoline, diesel, and kerosene. That is a picture of where we find petroleum. You can see that teeny tiny drill on top going all the way down. We have a little bit of natural gas on top here and the oil below. So they're going to drill past all of that to get to the oil and extract it and get it where it needs to go for refinement. Some advantages of petroleum are that it is convenient to transport and use. It's relatively energy dense. It's cleaner than burning coal. And we use oil for lots of things. So it's versatile, I guess, would be the advantage there. Some disadvantages of petroleum are that it does release carbon dioxide to the atmosphere. There are possibility of leaks during extraction and transportation. It's like the BP oil spill. That was a serious problem. The runoff from petroleum does enter marine waterways, and it releases sulfur, mercury, lead, and arsenic into the atmosphere when it is burned. So lots of disadvantages there, but it's cleaner than coal. The cleanest fossil fuel is natural gas, which sits above petroleum and is found in gaseous deposits separate from petroleum. Most of the time, we're getting it because it sits above the petroleum. Natural gas is about 80 to 95% methane and 5 to 20% ethane, propane, and butane. It's usually extracted in association with petroleum, and it's used for electricity generation and industrial processes and to make nitrogen fertilizer. Some advantages of natural gas is that it contains fewer impurities, and it only emits 60% as much carbon dioxide as coal. So we're doing a little bit better with our CO2 emissions using natural gas. Disadvantages of natural gas are that when methane escapes into the atmosphere, that's an issue because methane is a potent greenhouse gas. And the other issue is that as we are exploring for places where there might be natural gas, the groundwater can become contaminated. Uh, Pretty serious issue there. Finally, moving on to oil sands and liquefied coal, which are also fossil fuels, but they're both less readily available. Oil sands are slow flowing, viscous deposits of bitumen that are mixed with sand, water, and clay. We're talking about bitumen. We're looking at degraded petroleum that forms when petroleum migrates to the surface and is modified by bacteria. Bonus, we can extract that by surface mining, and this can extend our petroleum supply. However, there are serious environmental impacts because they're more energy intensive. Extraction is for sure going to contaminate the water, and they do have low efficiency. So we are not wanting to have to rely on this because we're out of our other things. There is a technology that converts coal into a liquid fuel, which is called CTL, coal to liquid. This process is super expensive and does have similar drawbacks using oil sands, and it emits more greenhouse gases than the others. So again, we need to stay away from this as much as possible. And don't forget that fossil fuels are a finite resource. So this graph looks at our per capita energy use and our energy use per dollar of GDP, which is on a downward trend. Finally, today we are going to look at nuclear power. Nuclear power plants use the same basic process to generate electricity as fossil fuel plants. What is different is that they use a radioactive isotope, specifically uranium-235, as the fuel source. And so it's all about this process called nuclear fission, where the nuclear reaction, which is a nuclear reaction in which a neutron strikes a large atomic nucleus. Uranium-235 is a pretty big nucleus. And that's going to split into two or more parts, releasing additional neutrons and energy in the form of heat. And then those additional neutrons are going to bust up whatever's left. That heat is going to be used to produce steam and turn the turbine. One of the cool things about nuclear is that 1 gram of uranium-235 contains 2 to 3 million times more energy than 1 gram of coal. So this is a huge untapped energy resource, but there are some issues with it as well. So here's a picture of that. We have a neutron being fired very rapidly at that large atomic nucleus, which is going to split that, and then those other free neutrons are going to hit some more, and then we have all these little pieces of the original large atomic nucleus. Within the nuclear reactor, there are fuel rods that enclose the nuclear fuel. The uranium fuel is going to be processed into pellets and then put into the fuel rods. The downside is that the byproducts of this reaction include radioactive waste that is hazardous for hundreds to thousands of years. So one of the big issues is, like after these fuel rods are spent, what do? Turns out some of them get buried, which is a problem for sure. So here's a picture of that. We have our reactor with our fuel rods. We're going to use that to make steam. That's going to turn the turbine, which turns the generator, etc. Some advantages of nuclear are that there is no air pollution within that process. However, there will be some pollution with, creating the nuclear facility, etc. It also reduces the need to import oil because we have quite a bit of uranium on our Earth. Some disadvantages of nuclear are the possibility of accidents, like what happened at Chernobyl and 3 Mile Island, which I would encourage you to do some research on, and the difficulty in disposing of the radioactive waste. It's a pretty big disadvantage. There is also some concern about nuclear material being misused. So that is a concern to think about. But I think the big one here is the difficulty in disposing of waste. Because while we have had accidents, and they have been terrible, few and far between. So there's that. What may or may not be coming soon, probably not, is nuclear fusion, which is a reaction when a lighter nuclei are forced together to produce heavier nuclei. And this is what powers the sun and other stars. It is a promising, unlimited source of energy in the future, but so far scientists have had difficulty containing the heat that is produced. And we need to be able to contain it first. Otherwise, this is a wash. It's not really going to work. All right, this table 36.1 is going to compare and contrast all of the energy types for you. I do think you should review it on your own. Obviously, this is teeny tiny, so check it out in your book. You will need to know about the type, where it comes from, advantages, disadvantages, and things like that. And that is all for non-renewable energy.